All right, chapter 4, lesson 4, first part, part A. Complex numbers. Okay, so performing operations with imaginary numbers. Okay, so typically we've all worked with real numbers. Today we'll break down subcategories of irrational, rational, integers, whole, and natural. Okay, so today we're getting rid of the real numbers. We're going to talk about imaginary numbers. So defined to be I squared equals -1. So therefore, I is equal to the square root of -1. Okay, so before we had dealt with some solving problems and we had problems that had no solutions, and those were no real solutions. Now we have these same problems, but they're going to have solutions. They're just not real numbers. Okay, so pure imaginary numbers. So these are square roots of negative real numbers. So whole number 6i or -2i, I square root of 3. Okay, so just one term, no plus and minuses in there. Those are those pure imaginary numbers. Okay, so let's take a look, simplifying these radicals. So how do I simplify a radical? Again, we're taking a look at square roots. Square representing 2, looking for 2 of the same. So when I break this down, and I'm going to break this down pretty nice here, and I'm not going to be lazy, and I'm going to write out the square roots. -1 square root 18. So we pull out this -1 term, okay? Because again, I can't multiply 2 of the same numbers and get a negative value. If I have 2 negatives, it becomes positive. If I have 2 positives, it's positive. So I pull that negative out. Now I can kind of simplify this 18. So this is my I term right there. Square root of -1. Pulled it out. So now let's break down my 18. Well, 18 is 2 square root of 2 times square root of 9. Okay, so nothing duplicated there. So let's break down 9. 2 is prime, so we can't break it down anymore. 9 is square root of square root of 3 times square root of 3. And again, you can use any factors of those numbers. Eventually, you all come to the same numbers. Okay, so I'm looking for duplicates, repeats, pairs, okay, squares of the same, okay, 2 of the same, 2 square roots of 3. That makes a whole 3. I'm going to pull down my I with it, and what's left over, okay, we use the 9 because it's square root of 3 and square root of 3. So what's left over, we use the 18 because it's square root of 2 and square root of 9. Only thing left over then is that square root of 2. So there's my simplified 3i square root of 2. So square root of -18 is rewritten in imaginary terms as 3i square root of 2. Okay? Now, in this first problem, I was kind of nice and neat. I wrote down all the square roots. Typically, I won't do that. Okay? So when I do this, typically this is what it'll look like. Again, pull out my square root of -1. That will be written as that. If you want to write that in the square root of 28, that's what I have left. Now I'm just breaking down 28. All these numbers I break down, I know they're square roots, so I'm not going to take the time to put them all in square roots, okay? So 28 breaks down, and again, you can put any values, any factors that go into 28, okay? If you need to use a factor calculator, use one. So it's an even number, so you can always pick 2. So 2 goes into 2 one time, 2 goes into 8 4 times. 14, what goes into 14? Again, it's still even, so again, I can pick a 2 and 7. So 2's prime, 7's also prime. So those don't break down anymore. Looking for those pairs. Here's a pair of 2's, so that makes a whole 2. This square root of -1 is my I, so I comes out, and what's left? the 7. Make sure it goes back inside that square root because, again, remember, it is a square root of 7. I just didn't write it because, again, laziness, right? So as long as you remember that it's all these numbers that we are factoring down are square roots, you're good. Okay, so whatever's left goes back in the square root. So in C, again, if you don't necessarily even have to write the square root of -1. If you don't even have to pull it out. You can just say, okay, there's a negative. I'm pulling out an I, and then what's 125? Well, it ends in a 5, so 5 goes into it. 5 goes into 12 twice, and then 5 to 25. 5's prime, but 25's not, so 25 is 5 times 5. Again, we're looking for pairs, and typically I kind of don't want to lose track of that one up top, so I'll group it. Doesn't matter which two you want to group together, but that pair of 5's makes a whole 5. I comes down out front. What's left in the square root? The third 5. So 5i square root of 5. So that's simplifying radicals with negative numbers. Okay. Now, what about these i's? So remember, we said I equals square root of -1, or more importantly, I squared equals -1. So how can I simplify these? Well, what do I do with these 3i times 4i? They act just like x's. Okay, so we've multiplied 3x times 4x before. Everyone's done it. We know what we're doing. I's act just like x. So taking my numbers, multiplying the numbers out front, 3 times 4 gives me 12. I times I is I squared. Here's where it gets a little different. I squared is -1. So this is like saying 12 times -1, which then gives me a -12. So every square changes my sign. If it was negative, negative, negative make positive. If it's positive, like the 12 here, positive and then that -1 makes the -12. Okay, so you can see that here in letter B. Multiplying my numbers, -3 times 2, -6. I times I is I squared again. I squared is -1, so -6 times -1, negative negative makes that +6. Okay, so the square is just changing the sign out front. Okay, so we can go back to what we did just a minute ago. Here's what I would not simplify these. I wouldn't multiply them together, just simplify them as we go. Okay, so on the -20, square root of -20, I'm pulling out an I, and then 20 breaks into 2 and 10, 2 and 5. On the right side, the -12, I'm going to pull out another I, and 12 is 3 and 4, and 4 goes into 2 and 2. So again, what are my pairs? So I have a pair of 2's here. I have another pair of 2's. So this pair of 2's makes a 2. Second pair makes a 2. I and I is I squared. What's left? A 5 and a 3. Those go back under my root. 5 and 3. And now the duplicates, the extra numbers, I'm just multiplying. 2 times 2, 4i squared. 3 times 5, 15. But again, simplify that I squared. I squared is actually -1, so 4 times -1 is -4 square root 15. And there's my answer. Now, letter D, I to a power. Okay, there's a chart down here. It kind of helps you a little bit, maybe think things through. But again, every pair of i's makes a -1. Okay, two -1's make a +1. So you can see here with 4, I to the 4th is I squared and I squared. Both of those make negative ones. But the two negatives here actually make a positive answer. Okay? So, we're looking at this exponent. Okay? How can I break this down? And I'm looking kind of breaking it down into even exponents. So, what's the closest number here that's even, but not going over 31? So, I to the 30th power. And then I have one more I out here. Okay, so I to the 30th and I, that makes my 31 i's, right? Now, remember, every pair makes a negative 1. So how many pairs do I have out of 30? Right? Every 2. We're making this even. Those should all 2 should always go into this. So how many pairs, right, make a negative? How many pairs of negative 1s do I have? Well, I need 2 pairs. So 2 of these, every 2 gives me a negative 1. So how many negative 1s do I have? In this case, I'm going to have 15 negative 1s. Okay? So I'm dividing that 30 by 2. And then I still have this I out front. Now, if I have 15 negative 1s, okay, taking a look at my chart, okay, 2 negative 1s makes a positive. 3 negative 1s here, n equals 6, makes a negative. 4 negatives, 1 here, and 8 makes a positive. So you can see this negative 1, I to the 8th, there's actually 4 negative 1s, right? Taking half of that. And this one, I to the 6th, there is 3 negative 1s, okay? So in this case, we have 15. So positive negative 1s with, or negative 1s with positive exponents is going to be positive, okay? No. Negative ones with even exponents are going to be positive. Negative ones with odd exponents are going to be negative. So this negative 1 to the 15th breaks down just to be negative 1 times I, or we can just say negative I for my final answer. Okay? So let's talk through this extra example here. Simplifying I to the 7th. Again, let's split it up into an even number. So I to the 16th, and we still have an I left over, right? Now, let's break it down into negative 1s. So how many negative 1s am I going to have? Well, exponent here for my I is 16. I need 2 to make a negative 1. So I'm going to divide this 16 by 2, and I'm going to get 8. I. If I have 8 negative 1s, right, 8 is positive. Therefore, 8 is even, so therefore this negative 1 is going to end up being a positive 1. So my answer is just I, positive I. All right, so now we can have some of these quadratics that we can solve a little bit further. So here we have x squared plus 4 equals 0. So we don't necessarily have to graph this. We don't have to solve. We can just solve it by hand. Okay. So just solve it like we typically would. We'll subtract 4 on both sides. Okay. We don't have to factor this down. And I get x squared equals negative 4. Well, what's the opposite of a square? Square root. So we square root those both sides. So x equals square root of negative 4. Again, we type that in our calculator, we get an error message. Can't do it because of the negative, right? But now we have these imaginary numbers. So now this square root of negative 4, I can pull out an I. 4 breaks into 2 and 2. Well, there's my pair. So x equals, and we're going to say positive negative value of 2i. And there's my two solutions, positive 2i and negative 2i. So anytime we take that square root, it's going to be that positive and negative answer. Take a look at B. So again, let's solve them for x squared. We just have an x squared. Let's just get it by itself and square root. So subtract 100. So 4x squared equals negative 100. Divide by 4. So x squared equals negative 25. Again, square root undoes the square. So again, square root of negative 25. Pull out my I. What's 25 break into? 5 times 5. There's my pair. Again, know those doubles. Okay, if you know the doubles, 1 squared, 2 squared, all the way up to 15 squared. These square roots will come real easy. Okay, they'll come a little bit easier, I guess. Not real easy, maybe. But 5 and 5 plus and minus 5i is what my x is going to equal then. Letter C, we'll do one more together and then you can try the last one on your own. So letter C, again, let's get x by itself. So we're going to subtract the 180. 5x squared equals negative 180. Divide this by 5. So x squared equals 5 into 18 goes 3 times. Leaves me with 3 left over, so 60, 36. So x squared equals negative 36. Square root both sides. And again, if I know that those perfect squares in my head, 36, that's 6 and 6. So pull out my I, 6 and 6. Okay, I got my pair. I don't have to, I know 6 breaks down, but I don't have to because it's a pair. Okay, if they match up together, you don't have to break them down anymore. X equals 6i, plus and minus. All right, try letter D on your own here. Check it with the video when you are finished. So you should have subtracted 10, divided everything by 2, solving for x the same way, get that x by itself, square root, so x equals plus and minus, take out the I, 5 is prime, so just leave it in the square root, I plus or minus I square root of 5. All right, so here's some in-class practice. Do those. I'll have the answers pop up here on the video. You can check your answers to make sure that you are simplifying these correctly and getting the right processes down to solve for these imaginary values. Okay, so just remember we're taking that square root plus and minus that value when you're solving. Okay. Okay, there's all your answers for the in-class practice problems that you hopefully tried on your own. Again, if you have any questions on why you missed something, can't figure out what happened and why you missed something, let me know. We'll try and figure it out together. Take a look at your work and see what you did wrong there. All right, worksheets down the bottom right.